Hello and welcome to Programming Knowledge. So in today's video, you'll be learning about how to use Matplotlib Library to plot different types of graphs. So we'll start with the simple plot. So I'll be using PyCharm IDE for this video series. So if you're not installed PyCharm, I'll be giving the link to the video to show how to install PyCharm on your Windows or Mac machine. So I'll open PyCharm IDE using Spotlight. Okay, so we'll create a new project. We'll give a project name as Matplotlib tutorial or tut, and we'll select project interpreter. So we'll select new environment using virtual N. You can also select pipin or conda, but I will select virtual N, and you can change the location if you want. Base interpreter is Python 3.6, and we'll click on create. And it is creating the virtual environment for our project. Okay, we close the tip. You can see the project structure. We have the virtual environment directory. So in the bottom, you can click on terminal tab and it will open the terminal. So here we'll type pip install matplotlib and press enter. So this will download the Matplotlib library and it will install on our machine. So we'll wait till it get downloaded and installed. So while it is downloading, let me show you the Matplotlib library and what is the use case of that. So we'll open a new window of Chrome. We'll type Matplotlib. Let it load. So you can see the Matplot library is a Python two-dimensional plotting library which produces quality figures in a variety of formats. So you can also use it with Python scripts and also with Jupyter Notebook. So it is derived from MATLAB. MATLAB is a multi-paradigm numerical computing environment. So we can go in examples. So here you can see the different graphs they are provided with, like stacked bar graph, horizontal graph. There are n number of graphs here. So each one has a demo code with that. So if you want, you can take a look at that. So these are scatter plots. We have bar graphs. I'll be using a simple plot to show you how to use Matplotlib library. Let me click on particular. Okay, you can see the percentile as a horizontal bar chart. So they have given us the code also. So this code looks a little bit advanced. So we'll start from the basics, and as soon as we learn more about Matplotlib, I'll be showing you how to use it to produce complex charts. So we can also create pie charts. So you can go through the gallery if you are interested in this. So it is still downloading. So it has downloaded and installed. So you can see it has installed different packages along with the Matplotlib, like NumPy 6. You can see the Matplotlib in the end. So you can click on our project from project structure and new and click on Python file. So we'll give you the name as mat.1, which is matplotlib tutorial 1. So click enter, and as you can see, it has opened the file, and here we can import the package. So we'll use from Matplotlib, we type import pyplot, and we can use alias as PLT. So whenever you want to use pyplot, we'll call as PLT and the name of the function which we want to use. So now we have imported the pyplot package. So we'll import our data. So here we have a list. So I have put as 3 list. So I will share with the list with you, data.py file. So this contains the years. So I have copied this data from this particular website called Statistic Times. So in here you can see the China versus India population from 1950s to estimated year like 2100. So I have copied it from 1950s to 2030. So you can see it is from 1950s. So China has like 554 millions, and till 2030 they have 1.4 billion, and or India has 1.5 billion. So I had copied that data and put it in the list in Python. So year contains 1950 to 2030. So I'll copy this year list into our Mat tutorial 1 py in population China. So these floating point values are in billions. So keep in mind, I have not taken the whole number. I just scaled it down to the decimal point 2. So I'll use only 2, population China and year. So we'll plot this data using pyplot package. So we'll import that package using plt dot plot. So this is a function. So inside this function we'll pass the x-axis and y-axis values. So x-axis would be year, comma, y-axis would be population of China. Okay, so after this, if you have to show it to the screen, so you will use plt.show function to display it on the desktop. So when you run this, you will see this figure 1. So this is a simple plot. So in x-axis you can see the age, and in y-axis you can see the scale of the population. So you can use the pan function to pan around. You can use the magnify to magnify and see the exact details of the plot, and you can use these arrow keys to undo and redo. So if you want to go back, you can use undo, and if you want to get one step back, you can use redo. So I think this is about configuration of subplot. So also you can click on this save to save the file as png, save the plot as png format image, and you can also use home to bring it back to the original position. So we want to add x-axis and y-axis label, so we can do that using plt.x label. So this will display the label values. So we'll pass a string as year, and for the y label we'll use plt.y label. In the parenthesis we'll give population in China in billions. Okay, so we'll make the year as y capital. Okay, we will run now, and you can see the label is put up as in x-axis we have year, in y-axis we have population. You can also add a title, but first I will change the population. Okay, you can also add the title. So for that we will use plt.title function. So inside this you can pass a string as population of China. So let me run again this program. You can see the title has come up as population of China. Now we will import our another list, that is population of India. We'll copy and paste it in our Matplotlib tutorial 1 file. Okay, so now if you pass this population India list to the plot, it will not give an error. It will actually print that, but it will be not in a good format. So the better option would be to print it separately using pylt.plot, pass year as a first argument, comma, population of India as second argument. Now we'll change the title as population of China versus India. Okay, and now we'll run this. So you can see. So we cannot figure out which one is what, but according to our previous graph, we can see that blue is China and orange is India. So to know which one is what, we can use legend function. So for that we will use pylt.legend. So inside that we'll pass the values of the particular line as a list. So the first string would be population of China. So we'll put that China, comma, next would be India. So put string as India and save, and now run. So you can see in the upper left corner we have blue for China and orange for India. So this is carried out using the function legend. So this is a little bit it can create problems in longer run if you are having more than one or two countries, like population of Brazil or population of Russia, for example. So if we have like 10, 15, then the order will be mismatched if you are working on lot of countries. So for that, the better option would be using attribute in the plot function. So I'll remove this, I'll copy this China. Okay. And now in the plot function, we'll give an attribute as label equal to, we'll pass the string at China. And we'll pass India in the second plot as label equal to, label equal to plot India. So what this will do, it will do the same thing as what legend was doing using the list. So instead of passing through legend, we are passing it through plot. Okay. So this is how you create a simple plot. In this video, I'll be showing you how to use different format strings to customize the plot. And also, I'll be showing you how to use different styles provided by the Matplotlib library. We'll run our current plot. So you can see it is containing only the China and India population graph, and you can see the India is orange and China is blue color, and India is slowly increasing from 1950s to 2020, and at 2000 after 2020 it will intersect the China population. So we can use function provided by Matplotlib library called grid. So we can type pylt.grid, and if we run a program now, we can see that our graph contains a grid now. So this is very much easier for us to understand at what time or at what period both the lines of the population will intersect each other. So it is around 2023, and you can also see it will be more than 1.4 billion. So at 2020, uh, China is ahead of India as per the data. So India is somewhere around below 1.4, and China is around 1.45 something billion. Okay. So now I'll go in Matplotlib website, and here you can see matplotlib.pyplot.plot. So in here, if you go down, you can see the format string. So don't worry about the URL. I'll give this URL in the description of the video. So format string contains first marker and then line and then color. So the other combination will also be working, but parsing of them might be ambiguous. That is, sometime it might be error prone. So it's better to use the given format string, that is marker, then the line, then the color. So in the markers, we can see we have point marker, etc. Then pixel, circle. So the characters which are provided we can use for the particular markers, and also for line style you can see solid line style. This is the default, that is only one dash, and for dashed line style we have to provide two dashes. So by default solid line style is included by Matplotlib. So we'll go in our plot, and now we can add the format string in our plot function. So for that we'll put comma, and inside the comma we can use, in inverted comma we can give the format string. So for that we'll put first the line style, so that is dashed, and now we'll run. So here you can see in China's line, plotted line, it is given as dashed. So that is due to the format string which we have included. So let me close it, and for and now we'll go in the website, and you can see there are different line styles. So we can use dash and dot for dash dot line style. So for India we'll put one comma in the plot function, and inside that we'll type in two inverted commas, dash and dot. So India is dash dot. So we'll run now, and you can see the India is plotted in a dash dot line style format. And we have one more format, so that is colon, so in which dotted line style is included. So we'll make the China as uh, default format, that is solid line, and for India we'll make it as colon. So this will print the dotted line. So here you can see the China is now solid, and for India we have dotted. So now we will include the different colors. So for that we'll go in the website, and we'll go down, and here you can see the colors tab. So there are different keywords given. For black we can use K, for white we can use W, for red we can use R. So after the line style we'll type the keyword for the color. For China we'll give it as R, because as you all know, it contains red in the color of the flag, and for India we'll go with green, that is G keyword. So here you can see the red line is plotted for China, and for India it is green. Now we'll make it dashed for India, the line style, and for China we'll now include a marker. So for that we'll go on top, and here you can see different markers we are given as point marker, circle marker. So we'll use circle marker, that is O keyword. So we'll include O, that is alphabet O, small alphabet, before the line style, and we'll run. And as you can see, the different data points in the data set of China population are now populated with the red color dot on the line style. So, and there are other markers also you can try with. For India, I will use different marker, so you can go and see which one we can use. Okay, we'll use star marker. So for that we have to include star keyword. So we'll put star, that is asterisk, and we'll run. And as you can see, the data points in the data set of India is now plotted with asterisk symbol. So this is the one way we can use the format string. Another one is by using the labels or the attributes. So we can put comma and we can type marker. So marker equal to which marker we have to use. So the keyword we have to put in the string format. So I'll put in inverted commas the keyword O, and then the line style we want to include. So type line style equal to, in the inverted commas, include dash or double dash for dashed line. And the third one is color. So for type color equals to, in the inverted commas, include R for red color. So we'll remove the earlier format string, and same way we now we'll run. And as you can see, it produces the same result as earlier, and you can see the code is little bit more readable due to the segregation of the marker, line style, and color into different attributes. So we'll do same thing for India. For marker, we'll put star. Keep in mind to include it in the inverted commas because it's a string. So for marker, we'll put star, and for line style, we'll equals to, in the inverted comma, we'll include double dash, comma, the color we'll put green, that is G. And now we'll clear the earlier format string, and now we'll run. And as you can see, it produces the same result as earlier. Okay, so this is how you use the format strings to customize the plot. One more thing is there, for color we can directly give the values like red, green, that is the complete string, and it will also include that as a valid argument. And also you can also include, it is hex value, so you can get it online easily. And now I'll copy it, paste. So color one is the particular color I copied from internet, and the second one is for color 2, it is hex value, so I'll put it for China. And now we'll run, and as you can see, the colors are slightly different now. I used the shade of red for the China, and for India I use little bit darker in blue color. Okay, so one more thing I want to add is you can also change the line width. So by default it is 2, I suppose, and I'll make it as 4 to make the line a little bit thick. And for India we will put it as line width as 3 and put a comma. Save and we'll run it. As you can see, the China line is a little bit thick, and for India it is little bit thin than the China. Okay. Let me remove the line width now. If you are having problems with the screen ratio, like padding is not supposed to be really good with the graph you're plotting, so you can use a function called tight layout. So what this will do is, according to your screen resolutions, it will make the plot padding match to the screen resolution so that your plot looks really nice on the screen whichever you're working with. So it will not show that much difference, but if you have any padding issues, you can include the tight layout function. Okay, now I'll show you how to include different styles or themes. So for that we have a attribute. So we'll type plt dot style dot available. So this attribute contains all the different styles which Matplotlib provides. So we'll include it in a print function. Keep in mind that it is a attribute and not a function, the plt.style.available. So now we'll run the program. And as you can see in the console below, the list of different styles, plot styles are available. So here you can see Seaborn, we have classic, we have. So let me choose one for demo. We'll stop the program first. Now I will show how to use that. So type plt.style.use. So in this function, provide the style value as a string. So we'll start with dark background. So this produces a very dark plot with white color edges. So let me stop the plot first and then we'll run it again. Now we'll use another method, another type, that is 538. So here you can see it creates a graph. So this looks a little bit more nicer, and you can see we have included a grid, but it is not showing us. Let me remove the colors first. So let me see what the theme provides. Okay, so theme provides these colors. So these are very bright and nice, as you can see. Okay, so now we'll use another style, that is Seaborn dash dark grid. So let me copy it and we'll paste it in the style string. So now we run. So this is little bit different, as you can see it provides us dark background. Okay, and colors are also different. Now you can see we have included a grid function, but it is not providing us with the grid. So for that put we have to include true as a value in the grid function, not as a string but as a value. So as you can see, it creates a grid and displays it along with the style we are using. Okay, so for me the personal favorites are 538 and another one is ggplot. So ggplot was basically derived from the R programming language. So we'll include that and we'll see how it looks, and we'll run now. And as you can see, it is similar to the Seaborn dark grid. Okay, and we'll now close it, and as you can see, this is how you can use different styles. So one more thing I want to show you is there is one function which is provided by the Matplotlib library, which creates comics like graphs. So for that we have to include plt.xkcd function. So if we run, our graph will be displayed in the form of hand-drawn plot. So as you can see, it is like little bit different and it looks like drawn using hand. So this is helpful if you are putting it informal way or sharing it with your friends. Okay, So I'll clear all the markers and the line styles. So now we can run and we can see our default graph with no markers, no line styles in the XKCD format. So this is how you use the styles and different format strings for plotting the graph. So in today's video, I'll be showing you how to use subplots to draw more than one plot, and also I will show you how to draw bar charts using the data. So let me run the what we had done in the previous video. So we had drawn this simple plot which has years from 1950 to 2030 and population in billions in y-axis. So we had drawn for Indian population and Chinese population. So let me show you how to use subplots. I will show you how to plot two subplots in the same adjacent plane. So we'll first remove this xkcd function and let me use some style. So we'll use ggplot for this video, and you can just comment out the plot function first. And now the subplots are plotted as in a way of matrix. So if you want to plot three plots, so what it does is 3 into 1, so that will be in the matrix form. That is, in the first row it will have 3 plots and it will have first subplot. So like that, in the matrix format it will be like 2 and 1, 3 and 3. So these are passed as parameters to the subplot function. So let me just show you. So we'll type plt dot subplot. So in that we'll pass our first one row and we'll display two subplots, 2 comma first subplot. Okay, this is like indexing. So we'll give the plot function now, and inside that we'll pass our year, comma population of China, comma label equal to China, comma color will give it as orange, or not orange, red will give. Okay, so we'll give plot dot title, that will be subplot 1, and our x label, y label will give it as year, and y label will be population millions. So same way we'll type it for subplot 2. In that we'll pass 1 comma second subplot, comma 2, and we'll type plt dot plot function. In that we'll pass year, comma population of India, comma label equal to India, comma color equal to green. So remember, we have to pass the legend function on top also, below the first subplot, and we'll type title. So plt dot title will give it as subplot 2. And just copy the x label and y label from top. Okay, and we'll save and we'll run. So as you can see, we got two subplots, and in one we have China and another one is India we have. Yeah, but you can see that one is little bit bigger and one is little bit smaller, the grid function. This is, I think, the due to the values which are passed. Okay, so this is how you plot two subplots side by side. You can also try with different method like style, that is 538. So let me see that how it looks. Okay, so this looks really nice. So this is 538 style. Okay, so we'll create a new file for bar charts. So we'll type bar chart. Yes, and as you can see, also it is added to our Git repository, and also I have uploaded for subplot. We'll copy the data from our main file to the bar chart. Okay, that is year, population, China, India, and we'll get ending lines. Place it here. Okay, we can just directly plot the bar chart using bar function. In that we'll pass the same year and population of India, comma, label equal to, we'll pass India, comma, color equal to green. Okay, so same we'll copy and paste it here, and here we'll pass population of China and make it label as China, and color will be gray, red. So if we now run this file, we'll get bar chart like this. Our China bar chart is showing perfectly, but our green colored India's bar chart is like little bit showcasing. This is actually happening because the China bar chart is overlaying on top of India's bar chart. Let me show you. So for that we can use a method that uses offset to separate out the values. But first what we'll do is we'll trim down our data, so will only contain values from 2015 to 2025. So for that we'll cancel out this. Okay. Okay, so now it is done. Let me comment this out. You can run this. It will give a bar chart. Okay. So what if we want to draw one more bar chart? So if we run, we cannot see the green one. It is overlaid by this China's population. So for that we have a method to overcome that. So for that we have to use something called as width. So by default it is 0.25, I guess. Okay, and we also have to pass indices. We'll create a variable called indices, and in that we pass the function from numpy and p dot a range, and it will contain the length of our. This should actually come on top right here. So it should contain our year list. Okay. So we have not imported numpy yet, so just import it. Okay, the numpy is imported, and what we have to do is we have to pass the indices in each and every function of bar. So we'll type indices, comma here, and again indices, comma here. So if we run it again, it's a full red color because these indices are not properly set up to work with our years in particular. So it is just giving us the index from 0 to 10. Okay, so what we will do is we'll, for first bar we'll do indices minus width. For the second we'll keep it as same, and we'll pass width equal to width, so that the function will know that we have changed the width value, and also we'll include just to subplot our title in the next label and y label. So this will be for first one, and for will not require for second one. Just paste it below. Okay. Type population comparison between India and China. Okay, so if we run this now, okay, we got an error. It is saying we got multiple. So we forgot to remove the year because we are already passing it through the indices. So we'll remove here, and we'll also remove here from here. And if we save and if we run, we can see the India versus China comparison, but years are still showing as indices. So for that to work, we have to pass a function called pid.xticks. So in that we have to pass ticks as parameter. For that we'll pass our indices variable and comma. We'll also pass label equal to the year. And if we save and if we run, you can see our years are shown here. You can see the growth is increasing, and actually at around 2022, 23, 24, India is like near to China. In 25 it will cross to China, I guess. So this is how we plot a bar chart, a vertical bar chart actually. So in today's video, I'll be showing you how to plot pie charts using Matplotlib library. So here we have earlier code which is used for bar chart. So I'll create a new file. Okay, new Python file. So I will give the name as pie chart, pie underscore chart. So we'll import our code from here. So the style and import code will be same. So we'll copy and paste it here, and the end part, that is plot show and plot grid, we'll copy and paste it here. For the pie chart contains slices, so we'll create a list of slices. So inside that we'll pass some values like 40 and 60. So this makes it at 100%. So 40% and 60%. So we'll plot the pie chart using plt.py function, and inside that you pass slices as a parameter. And now if you run it, you can see the pie chart has drawn on the canvas, and there are no labels and nothing. So we'll add labels here. So type labels equal to, so this is also a list, so inside that pass the strings which you want to show. So first is 40 comma 60. So for the particular slices, these labels will be displayed. So these labels we have to pass in the py function. So labels equal to the name of the variable, that is labels. And so now if we run, we can see along with the slices we have the labels also displayed. Now we'll run without the style 538. So this is the default pie chart style which Matplotlib uses. So the color you can see it is a little bit different, and we can also pass parameters such as wedge props. So what wedge props does is it will create the border of this particular color or any parameter you want to pass. So we'll pass edge color. So this is in the form of dictionary. So it is having a key value pair. So edge color will be equal to the color we want to showcase, that is white. So if we run, you can see we'll zoom in and see, you can see that the edges are now colored as white. You can also put another color as black, etc. if you want. So I will show you different parameters that can be passed in the py function under wedge props. So let me take you into the Matplotlib documentation. So we type wedge props, then Matplotlib, enter. Okay, so here you can see matplotlib.axis.axis.py, then we have wedge. So we'll go in first link, and here there are the different parameters. So if you go down, you can see the wedge props property. So it takes dictionary as a parameter, and we can also pass dictionary value as line width, and we can set the width of the particular line. So here some examples are also given. So here you can see some slices are outside displayed. So these are displayed using our export parameters. I will show you in a couple of minutes. So we'll pass line width 3 in the wedge props. So here you can see the line width is changed. So that edge was there, it has now a little bit thick. So by default it was 1, I guess. If you zoom in, you can see around the circle also that edge is displayed. So this is another page from the documentation where you can see the particular wedge function. So the different parameter it takes, like edge color we have seen. Then we have different parameters like line style, color. So you can try them out if you want. Now I'll show you how to add custom colors. So we'll create a list of colors and we'll pass like red and then we'll pass green. So the 40% slice will be red color and 60% will be green color. So let me run this. Okay, it is not run because we have not included colors in the py function. So we'll include that colors in the py function. Let me edit in the end. So colors equal to the name of the variable, that is colors. So now if we run, we can see the 40% is in the red and 60 is in green. So this doesn't work on this, not only works for the percentage like this, but also you can include different values in the slices. So I have shown for out of 100 you can include different values, so it can be out of n values. Let me show that quickly. So let me make it like 40, 60 comma, we'll pass another value such as 30 and then another value 25. Okay, so now we'll pass colors, now we'll pass labels. So the 30 will pass as other one will make it, and the next one would be other 2. So if we now save it and run it, you can see it has now created 4 slices, 60, 40, other 1 and other 2. I'll close this. Now let's make it as 80 and then this one we make as 120. Yeah, and we'll add some different colors like blue, comma, yellow, and we'll also, now we'll run, and now you can see the according to the slices it is allocated. So you can also pass, these are hexadecimal codes of color, so you can pass it as custom colors. I'll just copy that and paste it here. Now what we'll make it as, we'll grab some data. So these are the populations of 7 countries. So I have taken it from a website. I will show you in the end the website. So we'll paste it in the slices and the name of the countries. So we'll put it in the labels. I'll provide this data in the GitHub repository, so you can see that in the description of this video. And also we'll make edge color as black and line width as 1. So now if we run it, you can see the edges now changed to black color and all the different countries are plotted along with their slices. So the largest is China and then India, as you can see, and then we have United States, Indonesia, but this doesn't look that good. So if you have like more than 5 values, then you should go with the bar chart, and If you have like less than 5 values, then you can go with the pie chart. So if you want to highlight a particular slice, so we can remove that particular slice a little bit outside from the center of the circle. So we'll first remove the last two countries from the labels, and we'll also remove the two values from the list of slices. And what we'll do is we'll create a explode list. So inside this it takes a float as a float values as parameter. So we'll pass 0 for 0% and 0.1 for United States. 0.1 is in the sense like 10%. So if you run it again, we'll also have to pass that explode value into the pi function. Okay, we are getting an error because we have included a comma inside line width. So we'll remove that comma and we'll paste it outside. Okay, so we'll remove this explode from here. We'll paste it in the front. So after labels, we'll type explode equal to the explode list, comma, and now if you run it, you will be able to see that United States is a little bit highlighted outside. So this is due to explode. So it is taking 10% of the whole radius. You can see it is just a little bit outside, but that is that 10% of the actual radius. So if you make it like 0.5, that would be like 50% of the total radius. So if you run it again, you can see it has come out from the center about half of the radius. So this is how you can now highlight a particular slice or remove that particular slice a little bit outside. And also we'll add title. So pit.title will type population pie chart. And one more thing I want to show you is we can also create a 3D effect. So for that we have to have shadow equal to true. So what this will do is it will create a shadow around the slices and it will give a feeling of a 3D chart. You can see it has created a dark shadow around India and also around Indonesia. And let me make it explode equal to 0.2, it is 20%, so it will look a little bit better. And if you run it again, you can see it has taken only 20% of the total radius. So you can change the colors according to your needs. So I'll show you one more thing, that start angle equal to 90. So what this will do is the particular slice or label we have, that is China, in the first place in the list, that will be starting from 90 degree. The pie chart will start from the China slice. So you can see first China, then India. So one more thing is, if you want to display percentage in the slices, so you can do that using a parameter called auto percent, that is auto PCT equals, there is a particular format that we have to pass in as a string, so that is %1 dot 1 f percent. So this is a particular format you have to take into consideration. So if we run it again, you can see in the slices they have displayed the percentages that a particular country has. So 9.1% is of United States. So I'll show you from where I got this countries population. So this is a website called Worldometers. So in that we have the population of all the different countries, current population. So I have scrapped the data from here. The data for this video is included into the data.py. So this I have included in the Git repository. You can just refer it. So I will give you the link to the my GitHub repository in the description of this video. So in today's video you will be learning about stack plots. Stack plots are also called as area plots. So let's get started. Area plots are pretty much similar to the line plot. These plots can be used to track changes over time for two or more related groups that make up one whole category. For example, let's compile the work done during a day by a student. So we'll go in our project and we'll create a new Python file. So we'll give our Python file name as stack underscore plot, and then we'll press OK, and we'll copy some starting code from the stack plots from PyChart actually, that is importing the numpy as np, and from Matplotlib import pyplot as plt. Then we'll use the style 538, and then we'll copy the plot.show and grid functions, or we'll remove the title for now. Okay, so let's go in data.py. So we have file list here, so we'll copy them and we'll paste it here. Okay, so we'll just plot them using pie chart. So we had already done in the last video lecture. So in the pie function we'll pass a list. So how many list we want to show? So we have 4, so we'll type 1 comma 1 comma 1 comma 1 comma, then we'll close the list, and we'll pass the labels for the list. So first is eat, then second one is sleep. Okay, okay, the second one is actually study. Then we'll close that and we'll remove the extra inverted comma. Then we have code, and then sleep. So I will just remove the comma, and I have to place the code in front of sleep actually. So we'll paste it here, remove the comma, and we'll remove the extra commas now. Okay, so this will plot a normal pie chart. So I will show you why I'm plotting this. So we'll type plt dot title. So in that title we'll give as pie chart. Okay, we'll make that h. Okay, and then we'll run this. So for that we'll right click and we'll run stack plots. Okay, so the normal pie chart will give you 4 quarters with study, eat, sleep, and code. But this is like so what if you want to show data for 5 days in a continuous manner? So we can't show that actually using pie chart. So for that we'll use this stack plot particularly. So here you can see for a particular day 1, a particular student will have 1 hour of eating, and 8 hours of studying, 6 hours of coding, 9 hours of sleep. So like that we have 5 consecutive days. So you can see second day he has 3 hours of eating, 5 hours of study, code for 8 hours, and sleep for 8 hours, like that. So what we'll do, we'll remove the pie function. So we'll type plt dot stack plot. We'll open the parenthesis. So inside that we'll pass our list. So our first list we want to show is days actually. So you can see the data in the eat. We have actually our data is increasing in study list and in sleep. So what we'll do, we'll pass first days as a parameter to stack plot. So this is a list. Then we'll pass 8, then we'll pass study, then code, and then sleep. Okay, so that is enough, and we'll change the title as stack plot. Okay, stack plot, and now we'll right click and we'll run the file. So if we run it now, it will load. You can see that it is showing us the data for 5 consecutive days. On x-axis we have days, and on y-axis we have hours. So you can see we have not given the labels actually, so we are not finding which one is what. So you can see the we'll just close it and we'll just put the labels now. So we'll create a list for labels. So type labels equal to, so we'll open the square brackets and we'll pass the string. First label is eat for our first list, then we have sleep, not sleep actually, we have study, then third one is code, and then the fourth one is sleep. So we'll pass these labels in the stack plot as parameters. So labels equal to labels, that is our list. And if we run it now, so before running we'll type plt.legend. So this is very much important. So what this will do, this will print the labels on the screen so that we can find it as which color is pertaining to which particular label. So you can see blue is for eat, then orange is for study, and on y-axis we can see the hours, and x-axis we have days. Okay, so we have, then blue color we have this 8, which is actually decreasing. In middle for third day it was like 4 or 5 hours, and then the study you can see it is increasing in the order, and the code is actually decreasing till we reach the 5th day, and the student is actually getting more sleep by the end of the 5th day. So you can find it. Okay, so another thing is we can change the location of the stack plot legend. So we'll type in the legend loc equal to where we want to show that. So we'll type upper left, so upper space left. So this is a string that we have to pass in the location loc variable in the legend function. So you can see the location of the legend is changed now, and it is at the upper left corner. Okay, so now what we'll do is we'll create one more list for colors. Here you can pass hex code also, that is hexadecimal codes, and also the short form or short characters. So we have M for magenta, C for cyan, R for red, and K for black. This I already showed you in my earlier videos. You can refer them. So we'll pass that list as colors equal to colors in the stack plot function. So we'll remove the extra spaces, white spaces, and we'll run it again. We'll run it again. Okay, we'll also put tight layout just in case for nice padding. So plt.tight layout. Okay, so now we'll right click here and we'll run it again. So here you can see our colors are changed and it looks really nice now, really vibrant. Okay, so magenta is the 18 hours, cyan is the study hours, orange or kind of red is coding hours, and we have black for sleeping hours. But you can see our legend is little bit off the grid, it is little bit getting outside, so we can fix that. So what we have to do is in our legend for loc variable we'll remove that string, and instead of that we'll pass a tuple. So how you create a tuples, we have to just open and close the parenthesis, and inside that we have to pass the x and y coordinates or percentage uh, by which we want to shift the legend. So we'll pass
So 0.06, that is not actually 6%, that is 0.06%, and also that is from left, and from the bottom we will pass 0.06%. So now save it, run it again. So you can see our legend is now shifted towards the little bit inside of the area plot, and you can see it is nicely put. So by this is how you can customize your stack plot. So this is just one example. You can do more kind of this using stack plots. You can actually create stacked stack plots. Those are actually sit one top of the another. Okay, so as usual I will provide this Python file in my GitHub link in the description of the video.
So in today's video, I'll be showing you how to use Matplotlib library to plot a histogram. Okay, so here we'll create a new file, new Python file, and we'll type histogram and press enter. Okay, so our file is open. So first we'll import the matplotlib library. So import matplotlib.pyplot as plt. So we are importing plot function from matplotlib library. Okay, so now we will open our data file. So in here I have a list which contains blood sugar levels of patients. So this is a string which contains data. Okay, and so diabetic blood sugar levels range I will show you. So if the range is from 80 to 100, then the person is a normal person and he doesn't have a diabetic. And if it is from 100 to 125, then that person is pre-diabetic patient of diabetics. And if he has above 125 blood sugar level, then he is a diabetic person. So we'll plot the histogram using the above chart, above list. Okay, let me comment this first. Okay, so below this plt dot hist, that is histogram function, and open curly parenthesis, open and close parenthesis. So inside that we'll pass our list, that is blood sugar. Okay, so we'll run this particular file histogram.py, right click and run. Okay, we forgot to add show function in order to show the histogram on screen. So we'll type plt.show, open and close parenthesis. So stop and we'll run it again. Let me check. Okay, so now we can see our histogram is loaded. So by default you can see it is taking the scale from 80 to 150, because that is the highest number of value 150 we have, from less than 80 to 150, and there is the number of people in y-axis. So matplotlib implicitly has plotted 10 number of beans. So beans is actually the number of bars in a particular histogram, you can say that. And now we'll customize the beans. So we'll type beans equal to, we have 3 categories, so we'll type beans equal to 3, and we'll pass that beans into the histogram function. We'll type beans equal to the variable beans, and if we run it again, we can see that we are presented with only 3 beans. And you can also categorize them using a
parameter called edge color. We have already used in other graphs. So edge color equal to, we'll pass the string as the name of the color we want to press, like we can pass G for green. So here you can see, like we can't see it clearly, so we'll make it R for red, and we'll run it again. So here you can see our beans are surrounded by a edge color of red, so that we can easily distinguish between these beans. There is one more parameter which we can use, so I'll show you that. So let me remove the edge color first. Okay, so we'll type R width equal to 0. We'll type 8. So R width is actually relative width, that is relative to the beam we are targeting, so that it will provide a gap between two beans. Let me make it explicit. So we'll type beans equal to a list. So inside a list we'll pass 80, 100, 125. So these are the three categories, and the fourth value will be the highest number of category value. So we'll pass it as 150. So we'll pass that list into the beans equal to the name of the list, that is beans. So as you can see, now it is recognizing the values we have passed in the beans parameter or beans list. So it is starting from 80 to till less than 150. So this is how you can customize the beans to have a particular category. And also you can play around with the R width. So we'll make it at 0.95, so that you can see that now the width between the two beans is decreased. So 1 means there will be no gap in between the two beans. So we can also pass color parameter. So color equal to, we can pass G, or we can pass green inside as a string. So if we run, now our beans color is changed to green, you can see. And I will also show you how to make the beans as hollow. So we'll type hist type equal to step, and the step is a string, so we'll enclose it into the single inverted commas, and you can see our beans are now hollow. So I will remove that and show you again by rerunning the program. And if you see now, you can see that those beans are filled with color, and we provide the hist type as step, then it will be hollow and it will look like steps. So that is how we can customize. Okay, now we'll open our data file, and I will pass two strings or two lists actually. So one is for blood sugar of man, and another one is for blood sugar of woman. So this is two static data, the list. So we'll copy and paste it here. Okay, and now we'll pass those two list into our histogram function. So we'll type blood sugar of man, woman and man. Okay, so instead of directly passing it here, we'll make it as a list and pass it here. So let me cut this both of these list from histogram function. Okay, then we'll create a separate variable called type, and inside that we'll create a list, and in that empty list we'll pass our both the list. So now if you type type in the histogram function, so it takes both the list into the histogram function. And also we'll pass colors equal to a list. Inside that we'll pass G in inverted commas, and R for green and red for the colors of both the list, and we pass color equal to colors in the histogram function. So if we run it again, we can see that the green and red color beans are displayed on the screen, but we are not knowing which one is man and which one is woman. So for that we'll pass the tangent function and legend function and also the title. So we'll pass plt.title, and inside that we'll put the string as blood sugar level chart maybe, and also we'll put labels. So we'll go on top, and after colors we'll type label equal to, inside that we'll pass an empty list, and in empty list we'll type the string which one we want. So we'll type man and woman. So let me enclose it into the inverted commas. Okay, so now we'll pass this label into the histogram function by invoking the label equal to label variable. Okay, so if we now run it again, before that we have to type the legend function. So plt.legend. So you can see the green one is man and red one is woman, but we forgot to add x and y labels, so we'll add that in a minute. So you can see in y we have number of people, and x we have blood sugar range. So we'll after beans we'll type plt.x label for labels to be displayed on x-axis. So it is a function, and inside that we'll pass a string. So we'll type blood sugar range, and for y label we'll type plt.y label, and inside that we'll pass a string as number of patients, total number of patients. And if we run it again, we can see the x and y labels as total number of patients and the blood sugar range on the x-axis and y-axis respectively. So we'll close this. So using the histogram we can compare the values. So you can see for normal 6 men are there, and in pre-diabetics we have very less number, that is 2, and as compared to the diabetic people, the normal people are more, and women's normal people are more, and diabetic women are less. So this is how we can compare and analyze the data using the histogram. So in the future I will show you how to utilize the pandas library to display the histogram in a very efficient manner. So that's all guys, thank you for watching. Before that I will also show you how to change the orientation. So for that we'll type orientation equal to it is a string, so we'll type double inverted comma and we'll pass horizontal. So this we have to pass in the histogram function. Okay, so if we run it again, you can see the x and y axis are changed. So total number of patients is now on y axis, and blood sugar range is on x axis. So this is how you can change the orientation of the histogram. So thank you guys for watching, and I will see you in the next video.